This is section 4.6. It's really a continuation of part B. We'll continue to look at variation, but this time we'll put them into more applied situations. In problem 1, the current flowing in an electrical circuit varies inversely as the resistance of that circuit. So we're going to want to put some variables in here so that we can write our equation. So let's say the current's going to be C and the resistance is going to be R. We're told the current varies inversely as the resistance. So our equation is C equals inversely, so K divided by R. All right, the next information we have is current is 25 amps when resistance is 4 ohms. I'll use that to help me solve for K. So 25 for the current, for C, and 4 for the resistance. And if I just multiply both sides by the denominator of 4, I can see that K is 100. So I now know that C equals 100 divided by R. I'd now like to find the current when the resistance is 5 ohms. So current is unknown. Actually, let me do this color-coded. Current is unknown, but resistance is 5. So our current ends up being 20, and it looks like amps are the units here. All right, so very similar. We just had to dig a little bit more for the information since it wasn't kind of given to us quite as mathematically as in the previous problems. In example 2, we have a car travels at a speed of s miles per hour. The braking distance d varies directly as the square of the speed. And speed was s. So let's write our variation equation. Braking distance is d, varies directly, so that would be k multiplied by the square of the speed, s squared. All right, we know that a car traveling 60 miles an hour has a braking distance of 226.8 feet. So d would be 226.8. That's equal to k times our speed, 60 squared. 60 squared is 3,600. And then if I just divide my 226.8 by that 3,600, I get 0.063 for my K value. So I now know D equals 0.063 times S squared. And I'm finally ready to answer the question. Find the braking distance if the car is traveling 70 miles per hour. So D is my unknown, and the speed is 70. Get a little calculator help. I'm getting a braking distance of 308.7. And I think that was in feet, right? Yeah, braking distance was in feet. Notice this is logical for this problem. We're going faster than we were at 60, and our braking distance is a bit longer than it was at 60, so things seem to be working out the way they should. All right, that brings us actually to the end of section B. We'll come back and do section C in the next video.